my pleasure to be here. I realize I stand between you and lunch for those in the room, and maybe you and your bed for those around the world. So just do give me just a few moments of your time so I can explain the awesomeness of the ocean, why we should care, and what we can do together. So I'm going to start with my first slide. And it's a terrestrial forest. I promise I do show you a picture of the deep sea on my last slide. Okay. This is a 1 kilometer by 1 kilometer bit of forest. Any ideas from the audience? Just shout out, where is it? Exeter, Amazon, anywhere else? Somewhere. We just don't know, right? What happens if I show you some more pictures? These, again, are 1 kilometer by 1 kilometer. We have a little bit of heathland, another bit of forest, and a forest with some paths. Come on, we must know now. I've given you 4 pictures. Where is it? Earth. Love it. Yes, you're right. You win the prize today. Anywhere else? A little bit narrower than Earth. Exactly, yeah. Now, the reason why we start with this is because that is what we are looking at in the deep sea. We have some information, like those pictures, but from that very precise information, we have to try and get global images and global patterns, and we just can't do that. Currently, it's an intractable challenge. So what does this actually look like in the deep sea? Well, let me introduce you to a friend of mine. This is black coral, known to its friends as Anticipatory. You might say, Lucy, it looks white. Actually, it's black. The skeleton is black. The polyps are white, all right? So I just haven't gone a little bit funny and forgotten what my colors are called. It's black coral. The polyps are white. And the dark colors you can see there in the oceans is where we would expect to find black coral. It lives from shallow right down to the deep sea, and it lives on hard substrate. So it lives like in our coastal margins and on lots of ridges and funky little mountains that haven't quite popped their heads out over the sea, called seamounts. Now, if I map where it should be versus the information we've got about it, we will see that they don't quite overlap. This is the most recent data that I pulled from OBIS, and each of those dots is a presence of black coral in the database. We can see that, there's pretty much no black coral where we wouldn't expect it, but there's lots of that dark blue where we're not seeing presence. We're seeing lots of black coral around the US, Caribbean, North America, Northern Europe, and Northern Atlantic, also into Australia and New Zealand. However, we're not seeing black coral presence in South America, around Africa, and in the Indian Ocean. Indian Ocean is particularly special to me because that's where I have the privilege to work. Now, I can tell you that black coral evidence is not shown on the slide because it's not there. It's because we haven't recorded it there. And this is the bias that we're suffering across the globe. The deep sea is historically a privileged place to work. There are few people who ever go down to the deep sea, even though the deep sea is valuable to us sitting here in a landlocked country here within a room. The deep sea enables our global processes to happen. It does things like act as a sponge to suck up some of that excess temperature that we're creating through climate change. So even if you've never thought about the deep sea until today, my challenge to you is think about it a little bit more and think how your work can interact with the deep sea, because it does, even if you haven't acknowledged that. The deep sea, in general terms, is waters below about 200 meters. However, I use this term a little bit more generally because down to 30 meters, we can use scuba diving gear. Anyone scuba dive in the room here? Wave at me. Oh, loads of you, fantastic. And we can scuba down to about 30 meters, 40 maybe. So actually lots of countries across the globe have got a wealth of information down to 30 meters. But once we start getting deeper than that, then we get this bias in information, and that information can only come from the privileged few. Now, why do we care about the deep sea? I've explained some of its values, some of its benefits to society and the planet, and we might call those ecosystem services. But those services are being impacted by multiple stressors, and I've just given a few on the slide, and the next slide I talk to you about some that might happen in the future. First one is climate change. Climate change is impacting our Arctic and Antarctic waters, changing the processes that allow the water that's sinking at the polar environments to then go across the planet and the seafloor and come up and create nutrient-rich waters in some important areas of the globe, like around the equator. We have an incessant problem across the globe with poorly managed and unregulated, unreported and illegal fisheries. This is impacting those waters right now. And I'm sure we've got enough brains here in the room and online to think about what can we do with some of the amazing innovations that we're hearing about over these 3 days. And finally, I want to draw your attention to pollution. Currently at the UN, there is negotiations for a global plastics treaty. But pollution in the water doesn't just go to plastics or that gasket coming from an engine. And I saw that down in the deep sea, in the southwest Indian Ocean ridge, about a week away from land. It comes in the form of lots of chemicals as well. Chemicals are much harder to see in the environment. So what does this look like in the future? We have mesopelagic fisheries, which are all the fish that live at about 200 to 1,000 meters. Because of exciting new technologies, they can now be exploited. But that exploitation comes with a risk because we are not able to understand what is that safe capture method, what is the safe number that is out there. We also have, again with technology and the new ideas coming through the International Seabed Authority, opportunities for seabed mining. This will impact the deep sea. There is no way you can mine and not see environmental impacts. And of course, those discussions and understandings are still ongoing about what that might look like in some of our high seas. And finally, bringing on to another consequence of climate change is deoxygenation. We all need oxygen to thrive, and that doesn't exclude our deep sea. And with increased deoxygenation, we actually get an increased stratification in our ocean. So we're separating our shallow waters that we know are full of energy and full of production from our deep ocean that provides so many regulatory processes. So I am now going to hand over to my colleague Sheena, who couldn't be here today, but hopefully will be giving us a little bit of an audio about her personal perspective from the Western Indian Ocean region, and really thinking about those biases. So let's see if we can get the audio to work.
Thank you, Lucy, for having me interject during your presentation. My name is Sheena Talma. I am a marine biologist from the Seychelles Islands and an aspiring deep-sea scientist. One of the things we talk about a lot within the region or the Western Indian Ocean is the fact that although there's a real interest to be engaged in deep-sea research, the equipment that will allow that access to be made possible is rather difficult to access.
So Sheena just gave us an example there of her perspective. The map that you can see there on the screen was a survey done by Ocean Discovery League a few years ago. The darker colors are representing countries that got access to deep submergence equipment, such as remotely operated vehicles, landers that sit on the seafloor, equipment that's able to sample the seafloor like corers, and other equipment such as submersibles. And you can see those dark colors are really around North America, around Europe, and again in Australasia, really mapping what we saw before with our black corals, with the lightest colors being in South America, around the African continent and some of Asia. And here's Sheena again to talk you through the next few slides.
Some of the key takeaways from the study includes the fact that 65% of respondents globally considered deep submergence vehicles important to conduct deep-sea research. When it comes to access, the most accessible deep-sea vehicles were remotely operated vehicles, followed by automated underwater vehicles and benthic landers. However, less than half of the respondents globally reported having access to these specific vehicles. Lastly, when it comes to the potential impact, 71% of respondents globally reported that an increased access to deep submergence vehicles would significantly impact or transform how they do their work. It is clear that there are disparities when it comes to who is conducting and leading deep-sea research. And this is largely based on what resources are available in different countries, as well as institutions. So what can we do about it? One such low-cost technology that we are currently using and testing in the field is the Macanoo. Now, the Macanoo was created by the Ocean Discovery League in collaboration with potential users in the field, from users in Sri Lanka to Montserrat to Seychelles and the Pacific. This specific sensor has a camera. It also has a temperature logger and a pressure logger. A small excerpt of the type of footage that is collected is seen here, and this was taken from the Maldives during the Maldives Necton expedition.
Well, thank you, Sheena. You said more than I could ever. You can see there on the video a six-skull shark that is a well-known deep-sea taxa being captured there by the Macanoo. And just before I go on and talk about opportunities for the future, I'm going to share a little bit more about Necton, which is the NGO for whom I'm principal scientist. In Necton, we aspire to use innovative science and inspiring communications with meaningful knowledge exchange. But what does this actually mean? Well, some of the science you've seen, it means going down into the sea and really understanding what's down there, documenting life and understanding baselines and how those baselines may be changing. Inspirational communications comes from the nations of whom we're privileged enough to work, allowing their voices to tell their stories of their lived experiences of their deep sea and ocean that they are now experiencing. And then together, bringing these knowledge and knowledge-sharing activities so that together we create a legacy for deep-sea research and collaborative work together for the future. So across the next 5 years, I think there's going to be a lot of change, and I'm really excited about that. I'm really excited to be here today to learn from all of you about what we can do together. And excitingly, on the tram yesterday, on my way here, we already made a connection, a collaboration. That is really exciting. So firstly, I can say thank you to the organizers for bringing all these amazing people together. So we've already heard from Sheena about the importance of sensors such as the Macanoo that work with collaborators from across the globe to understand their needs and to provide a solution that is low cost but high tech and that allows us to be able to fill in some of those gaps that have historically existed. Of course, there are many other ways of doing this, and I just wanted to highlight a couple. And one of these is from the ASEP group, and that's from the South African Institute of Aquatic Biology. And that group curates a number of different opportunities, so equipment such as a remotely operated vehicle and vessels, and allows that access to those from researchers across South Africa who can then use them to answer their own questions, and indeed access to the deep sea across the region. Now, these toolkits could be implemented in many different places. The only challenge we have is the funds and the technology to do that. But that we know is not limited, because we've heard so many exciting ideas over the last few days. We also know that artificial intelligence is supporting what we do. The video, like you see, it has to be translated by scientists into informative data. Can we get artificial intelligence, like the ocean vision that's coming from Monterey Bay Aquarium, to allow us to shortcut some of those components, to allow us to really understand what is out there in the ocean, what do we need to focus on, so together we can come into a room and create that new knowledge. So I think that's very possible within the next 5 years. I would also say the things that I've highlighted here for the next 10 years are totally possible today with the will, the finance, and the priorities. So I think there is a new opportunity for a field of science. I call it a field of science, but a field of discovery maybe, rather than science. There is an opportunity for a transdisciplinary approach, ensuring not only do we cover our physical, chemical, biological sciences with our social science colleagues within a wider environment of stakeholders, but ensuring we do not leave behind our local and traditional knowledge holders. And they are part of creating the questions and creating the solutions and the answers for the future. And doing that in an equitable way where everybody understands how we work together is going to be absolutely transformational in this space. There is also an opportunity for a new funding and accountability model. Traditionally, funding in North America and Western Europe has very much been, you write me a proposal, I like that, I think you're a great scientist, you go out and do it. Where's the impact? We don't know. Maybe it's a great paper, but are academic papers the best way of communicating all of our research? Maybe they're not the only way for us to share our new findings. But in fact, that model leaves out many forms of knowledge. It means that we're not necessarily asking the right questions. So how do we co-create our questions and our solutions for the future to ensure we can have a more equitable planet and society? And in the next 25 years, when we've got all of that in the bag and we're creating science together, I think we can have lots of autonomous robotics out there on the surface and on the seafloor, constantly collecting information. There could be an opportunity of using artificial habitats, like Deep from Bristol are thinking about. That would be a really interesting way of us really understanding some of these really challenging places to access. And then using the real-time monitoring and using the AI and using our new form of working together, using our stakeholders, our scientists, and all of our communities, then how do we translate that real-time information into management, monitoring, and conservation systems that are going to be responsive and are going to be appropriate for that environment? So I did promise I would finish on a slide that showed you the deep sea, and indeed I have done that. But I really want to share with you what I think the most important next steps are. So earlier this year, the final text for the High Seas Treaty, otherwise known as BBNJ, Biodiversity Beyond National Jurisdiction, was agreed at UN. There's now been, I think, 68 countries that have signed up to that, who will then ratify that, and that will become into international law. This is an absolutely momentous time for the deep sea and the high seas. It will be the first time in history that we will have a legal framework to be able to govern and police our high seas. We're also sitting at an opportunity with SDG 14, which talks about life below the ocean, with a number of targets which the recent report has shown that we're kind of moving there, but not moving there fast enough. And if we think about the ocean, and we think about a future ocean for all, then SDG 14 is not itself in isolation, which is like, that's a bit weird, the ocean's over here, but development and reducing poverty is over here. Things are actually interconnected. And in recognition for that, the UN has currently a decade for ocean science for a sustainable development that really looks at how do you pull all of these things together and what is the information that we need as a society to be able to make our decisions based on that future ocean that we want. So as promised, I'm going to leave you with this amazing image. It was from an expedition I was on back in 2012 from seamounts down in the Southwest Indian Ocean. You can see the vibrance of life. So please, if there's one thing you take away from this, know that the ocean is out there, the deep sea is important to you, and yes, it does have life in it. Thank you.
Thank you, Lucy.